6 super palindromes. So for this problem, let's say a positive integer is a super palindrome if it is a palindrome. So what does that mean? So first of all, this number is positive, and this integer must be a palindrome. So this is the first condition. So if this number were to be a super palindrome, and this is the second condition, it is also the square of a palindrome. So what does that mean? So it is a palindrome itself, and it is also the square of another palindrome. So for example, if this number 121, so it is a square of another palindrome. It is 11. So 11 is a palindrome, 121 is a palindrome, and also similarly for 2, 3. So 4 is a palindrome, so it is a square of another number, it is a 2. So 2 is a palindrome, 4 is a palindrome, 3 is a palindrome, 9 is a palindrome. And similarly for 484, so it is 24. If I calculated, it's not 24, it is 22. Yeah, so it's my mathematics skills, I forget about it. So it is a square of 22, and 22 is also a palindrome, because 22 square, it is 484. Yeah, so this is why, what are we going to do? First of all, we're going to check this number is a palindrome. Yeah, so first of all, this 22 is a palindrome, and then we're going to check its square is 484. It's also a palindrome, and if it is inside of the range more than or equal to left, less than or equal to right, so we're going to count it. Yeah, so for the first example, there are 4 numbers, so we're going to return a 4. So exactly how can we solve it? Definitely we cannot solve it by using the brute force. I mean, from the left to the right, we're going to check all the numbers. If this number is a palindrome, so for example 121, and if it is the palindrome of another number, and then we're going to count it as 1. Definitely it is not possible, because from the left to right, it's going to be 10 to the power of 8 numbers. Yeah, because the length of the left and the right is 10 to the power of 8. So instead of solving it directly, what about we just solve it by using the greedy idea? So first of all, what about we just construct all the possible palindromes itself, and then we're going to calculate the square of these palindrome numbers. So for example, we can check it like from 1 to 9, it is a palindrome itself. And then we're going to check this number 2. So 2 square is 4. 4 is a palindrome. 1 square is 1. 1 is a palindrome. What about 3? 3 is also a palindrome, because the square of 3 is 9. Yeah, so it means we're going to code it as like 1, 2, 3. So here we're going to code it as 1. 1 is another number's square. 1's square is 1. 4 is another number's square, 2. Yeah, so 2 is a palindrome, 4 is a palindrome, 9 is a palindrome, 9 is another number's square, it is the square of 3. Yeah. So what about we just code all those possible numbers? Is that possible? So we're going to code all those possible numbers like 1, 2, 3 to 9, and then we're going to continue to count. So for example, 10 is not a palindrome. Yeah, but what about 11? 11 is a palindrome. So what about 12, 13, 14? And we're going to continue to count. Yeah, I don't know, just an example. Maybe 22 is a palindrome, or maybe 33 is a palindrome, or maybe 44. Yeah, etc. There are going to be a lot of numbers. But how many numbers we're going to count? So maybe after that, it's going to 53, or maybe 101, or maybe 111. It can be a lot of palindrome numbers. So what are we going to do? How we can count all those palindrome numbers? It's difficult. Definitely we cannot use the brute force. So we're going to use the construct idea. So we're going to construct all the possible palindromes. And how can we construct it? Yeah, because the length of the left and right is 18. So it means the base number is 10 to the power of 18 minus 1. Let's just check it from here. Yeah. So the left and the right represent integers in the range. So this means this is going to be the largest number, 10 to the power of 18 minus 1. So how many digits of this number, 10 to the power of 18 minus 1? So let's just check. So 10 to the power of 1 minus 1, how many numbers? It is 9. So there's only one digit. Yeah, it is only 1. So what about 10 to the power of 18? So it's gonna have 18 digits. So this means that the biggest number gonna have 18 digits. Yeah, but this number left to right is the square of another number. So this means the previous number it must have 9 digits, because if it has 10 digits, it may be 10 and 10, it's gonna be 20 digits. Yeah, it is possible. But this means our number is 9 digits. So if if our current number is 9 digits, because it is also a palindrome. Yeah. So this means we just need to use 10 to the power of 4 numbers, and we're gonna use the palindrome idea to construct all the palindrome numbers. So what does that mean? Let me use an example. So we just need to 10 to the power of 4 numbers to construct all the palindromes, and then we're gonna check the square. So by itself, for example, we're gonna construct something like 1000. This is from the left side. So from the right side, we're gonna prepare 0001. So this is one possible cases. Yeah, and then we're gonna check the square of this number. Or maybe there's another case. Let's just try the biggest number. So for example, we're gonna prepare 49 at the left side and 49 at the right side. Yeah. So how many digits? There are 8 digits, but our lossless number can be 10 to the power of 18. But we can put any numbers in between this number. So for example, from the left side they're going to be 49, from the right side they're going to be 49. But in between we're going to prepare all the possible numbers, 0 to 9. We're going to put it inside. So in this case, how many 9? They're going to be 9, 9. So 9, 9 is going to be 10 to the power of 10. Let me calculate it right. Yeah, because it has 9, 9. So how many 9? So if there's 1 9, it is 10 to the power of 1 minus 1. But if it is 9, 9, it's going to be 10 to the power of 9 minus 1. And then we're going to check the square root of this number. So what is going to be the square root of this number? Definitely it's going to be, yeah, it's going to be 10 to the power of 18 or something. Yeah, it's going to be 10 to the power of 18 minus something more. Minus something more, maybe, I don't know. Just minus something more. But according to this case, definitely we checked all the possible numbers, because this is like 10 to the power of 18 minus something. Actually, this is all the possible numbers. If you don't believe it, let's just try another example. So this is 9 digits. Yeah, is this 9 digits okay? Or maybe we're gonna prepare 10 digits. What about 10 digits? So we're gonna have like 10000, and then we're gonna have something like this. Yeah. So what about this number? Yeah, this is a palindrome, right? Because it has 10 digits. And this number, let's just check it, it's going to be 10 to the power of 9 plus 1. And then we're going to check the square root of this number. It is more than 10 to the power of 18. It is more than this number, 10 to the power of 18 minus 1. So definitely it is not possible. So this means for our construction, we just need to have the maximum number just to be 10 to the power of 4. So this is enough. So we're going to construct the palindrome numbers like this one or this one. It can be even or it can be odd. And we're going to construct all the possible cases. And then we're going to check one by one. So if the square root of this number is in between left and right, so we're going to count it. Yeah. So now the hard problem becomes an easy problem. So let's just write the code. So we're going to write a palindrome array. So inside I'm going to use a list. And from the beginning, I'm going to put 1 to 9 inside. Yeah, because from 1 to 9, definitely it is a palindrome. Now, I want to put all the cases inside of this palindrome array. I just need to construct it. Yeah. So let's construct it. So for I in range from 1 to 10,000. And let's just prepare a number. So it's going to be an integer of string I plus string I reverse. Yeah, because we need to make a palindrome. And then we're going to put this number inside of the palindrome array. So this is one case if it is the length of this string is even. So what about if it is odd? So we're going to enumerate all the other possible cases. So we're going to insert 0 to 9 just in between those two strings. Yeah. So for I, let's just use another one. For j in range 10. So this is for 0, 9. And our new number gonna become, yeah, let's just copy and paste. So this is the number, and in between I need to plus a string of j and plus what's left behind, because this is another palindrome and the length gonna be odd, and the longest gonna be 10 to the power of 9. The longest length gonna be 9. The longest length for this one gonna be 8. Yeah, because only in this way we're gonna enumerate all the possible cases. So this is a little bit of calculation. Yeah, if you don't want to calculate, maybe you want to have a bigger number. Maybe you make it 2. That is also okay. Yeah, for our case. So now we want to put this new number, another number, inside of the palindrome array. Yeah. So let's just check what is inside of the palindrome array for understanding. Now let me just run it. Yeah. Now the strange thing happens. This is exactly what we need. Yeah. We need some numbers like 1, 2, 3, 4, 11, 101. Yeah, and definitely there's other numbers like 22 or something. Yeah, because currently we didn't sort it. Yeah, we can sort this palindrome array. You can see it more clear. So after sorting, let's just see what is inside. But for my case, I don't want to sort it. Now you can say 11, 22, 33, something like that. This is exactly what we need. It is a palindrome, and the time complexity is only 10 to the power of 5. Yeah. Now, since this is a 10 to the power of 5 for the time complexity, so we can check it directly from here. We're gonna use a counter as a result, and finally we're gonna return this result. So for any palindrome inside the palindrome array, and we're going to calculate the square, it's going to be p times p. And then we're going to check this number, right? Yeah. So if this number, let me use the integer of left. So if this number is more than left and less than integer of the right, and also it is a palindrome itself, how can we check that? Yeah, we can directly use x gonna equal to integer of string x and reverse if it is a palindrome, and if it is in between left and right, so we're gonna update the counter, and finally we're gonna return the result. Yeah, I think that's all about it. Let me just run it. As you can see, it works. Let me just submit it. Yeah, as you can see, it works. Although speed is not so fast, but it is still okay. Yeah, because we just use the time complexity of 10 to the power 5. So this is 10 to the power 5. And here, for the calculation, for each running of the code, it is also 10 to the power 5. It depended on this palindrome array. The length is going to be 10 to the power 5. Why? Because here we just use a for loop. This is another for loop. Oh, this is a 10 to the power of this is 10 to the power of 4, and this is another 10, so it is 10 to the power 5. Yeah. So the final time complexity gonna be 10 to the power 5. This is why it works. Yeah. I think that's all about it. Thanks for watching. See you next time.